Good morning to all of you. My name is Shrikant Shankalal Chaundiye and I am a research student of Bambu University, and my research topic is study of dielectric properties of soil of Buldhana district, and my research guide is Dr. C.S. Mahajan sir. He is retired professor from JES College, and my research center is JES College and Research Center, Jalna. So first of all, we will take some introduction about my topic. So my topic is study of dielectric property of soil of Buldhana district. First question is why I have chosen this topic. So I will tell in this video why I choose this topic and what are the benefits for to common people or to farmers from this topic. Okay, information on crops statistics is required for planning and decision making purpose, such as distribution and storage of food, grain, government procurements, policies, pricing and food security and so on. Remote sensing data does provide many advantages over conventional methods, particularly in terms timely decision making mechanisms, spatial deception and coverage, including cost effectiveness. Data is used addressing many critical aspects such as crop area estimation, crop yield and production estimation, crop condition, deriving basic soil information, cropping system studies, experimental crop and insurance. So what we do, we collect data, we analyze data and we make some result or we make some conclusions. So by this topic we will study the soil of Buldhana district, agricultural soil, and we will find out what crops are best in a specific soil. We will find characteristics of soil and make a decision that this soil could produce cotton or soybean much more, and we give that conclusion to farmers so that they came and get more benefit from soil. Or also we can calculate the effect of fertilizers on the soil. We used to say the chemical fertilizers, unfertile soil, but how? So what are the parameters? We can study soil by dielectric properties and find out we can study soil by microwave bench and find their dielectric constant and give result to them that the specific fertilizer affecting your soil's basic properties. So here I have a literature review. A new soil classification system was developed from empirical data correlation which address anticipated field soil performance relative to soil potential and frost susceptibility, was illustrated by David Josiah White in 2000. In the year 2008, our beloved respected Chaudhary sir observed a dielectric study of moisture laden soil at X-band microwave frequency. In this, the result shows the change in electrical properties of dry and moisture laden soil. He further explained the dielectric property of black and red soil at microwave frequency. In this appear, the result shows the change in electrical property of soil before and after addition of water. So what Chaudhary sir find that the dielectric constant or dielectric property of soil changes if it contains moisture. If the more we add water to the soil, the more dielectric properties will change to that of water. In earlier dielectric studies of soil, Martin, A.I. and Shang Julie described 2016 about complex permittivity to detect lead in soil with various concentration in soil. In general, the relative permittivity at dielectric dispersion frequency described, whereas the loss factor at 2000 MHz increased with an increase in lead concentration. This indicates that complex permittivity can be used to monitor lead concentration in soil. In 2018, Dr. Deshmukh sir, HOD of JES College, showed the relation between dielectric constant and water content of soil from western Ghats of Maharashtra. The result shows the change electric property of soil before and after the addition of water. The soil and dielectric loss is directly proportional to the microwave conductivity and transmission temperature. Sir took this research to next step and find out that if we add water, the temperature transmission is proportional to the amount of water we add to the soil. It has been found that emissivity decreases with an increase in moisture content. In the field of remote sensing and agricultural results obtained are useful. So this research will help in agriculture uses also. When I am giving my question asked why I have chosen Buldhana district. So Buldhana is westernmost district of Vidarbha, and it is very versatile district. The district covers total geographic area is 9,670 square kilometer. It is also surrounded by Madhya Pradesh, Akola, Parbhani, Aurangabad, Jalgaon and Jalna. Okay. There are which type of soil we found in Buldhana? The black soil. Black soil is a dark, humorous, rich soil that also has high percentage of phosphoric acid, ammonia, iron, and so on. It is very fertile soil. Okay, the characteristics of black soil: they are very prolific and have clay-like texture. They are also referred to as regur soil. Black soil has a significant amount of fine clay particles. It is best for cotton. Okay. Then alluvial soil, surface water deposit soil known as alluvial soils. So Buldhana district have Purna river. We can find out this soil nearby Purna river. Due to the soil are more alkaline where it is drier. Alluvial soil shows a wide variety of texture from silty clay to gravel. Okay. Then red soil. Red soil is common soil all over in Maharashtra. Red soil ranges in quality from poor, thin, light colored, unplanted soil to fertile. The texture of red soil in Maharashtra can differ from sand to clay, most being clay. And it contains potash and potassium. Procedure for soil sampling. So we have to prepare a soil sample collection is a basic factor to test the soil. Here you can read. The selection process of collection soil involves considering various factors such as soil type, land use, geographical representation and accessibility. So we have to find remote areas and first of all mark the sites to collect samples. Then you have to sample collection, dig a hole for use of soil. I go to collect sample. Then we should dig 0 to 15 and 15 to 30 centimeters. Then we have to handle this soil very carefully. We have to label the soil. Whenever we collect the soil, we have to take geotag and keep place it on the pouch. Sample labeling, clearly label sample. We have to mark location, date on the sample. Then you have to record all the process, how many samples we are collecting, from where, and how we send to testing them. There are few methods of soil sample collection. Taking soil samples, there are some methods: random sampling, depth sampling, diagonal sampling, V-shaped sampling, edge sampling, zigzag sampling. The zigzag sampling is very famous method. It's field sampling technique used to collect representative soil samples in systematic pattern that resemble the shape of zigzag. So we can collect by zigzag pattern. Here in this diagram you can see how we can collect the soil sample. We have to clean all the soil samples, and it may not contain moisture. Then what is first of all what is dielectric property? Dielectric property refer to behavior of materials in response to an electric field. Dielectric materials are insulators that can polarize when subject to an electric field, meaning their internal charges can rearrange in responsible to the applied field. This polarization can lead to various phenomena such as storage of electric energy in capacitors, the propagation of electromagnetic waves, and the interaction of material with microwave radiation. Then what is microwave frequency? So we are using X band microwave bands for our study. So microwave frequency refers to the electromagnetic with frequencies ranging from about 300 million hertz to 300 billion hertz. Okay, these are used in application including telecommunication, radar, heating in microwave ovens. Now we have to find permittivity. Permittivity, often denoted by a symbol epsilon, is fundamental property of material that describes its ability to respond an electric field. It indicates how much electric flux is generated and applied to the material. Then we have to find loss tangent. Loss tangent denoted by symbol. Then we have to find VSWR. It is a high gain voltage amplifier turned center frequency of 1 kHz. Voltage standing wave ratio is a crucial parameter to determining the efficiency of microwave system. These are the concepts we have to find out. Then calibration is also needed. We have to calibrate first microwave bench to calculate our data. Then methodology. There are different methods to find dielectric properties, including two-point method and infinite method. They are suitable for research work. Here you can see block diagram of a microwave bench, microwave power supply, then microwave source. Then normally we use klystron for microwave source, then isolator, then frequency meter, then attenuator, slot line wave guide band, and solid cell. Two-point method we use basically, and it is easy to use. The dielectric constant epsilon and dielectric loss of the conducting polymers were measured in the range of 7.2 GHz to 12 GHz. Microwave frequency using microwave bench and employing the two-point method. Here you can see block diagram of two-point method. Here VSWR meter connected, and also sample holder wave guide band. Then the sample holders for frequency measurement were fabricated from the standard wave guides. The one of the sample holder is connected to metallic flank and other end was carefully shorted. First, with no dielectric in the short circuited line, the position of the first minimum DR in the slotted line was measured. The two-point method offers a quick and straightforward calibration process suitable for basic application or when time is limited. However, it may not provide the most accurate calibration across the entire X-band frequency range, especially in the presence of non-lattice or significant variation in the bench behavior. Here I have added references we have used. Here you can see. Thank you for watching this seminar. Basically in this concept we are finding dielectric property of a soil and calculate to it with another soil, compare with another soil we know, and we find characteristics of both the soil. If a non-fertile soil have specific dielectric property, dielectric constant, then we can consider that if another soil have same dielectric constant, it will not fertile for in same condition. So thank you so much. My roll number is 153 for paper first and roll number 13 is for paper 13. Thank you so much.